Augies Worldwide. I'm Dave Casler, amateur radio call sign KE0OG, here with another episode of Ask Dave. Today we're going to do a review, and it's a review of this item right here. Now, the wording is a little hard to see on the label, so I put some other wording in there so I'd remember what it is. This is a Chelegance, which is the name of the company that makes it, and it's a JLoad. And this thing is 200 watt, a dummy load from DC to 520 megahertz, 50 ohms. Now this particular one comes with a male connector. You can fix that very easily by taking a little barrel connector and putting that in here, but for our demonstration we're going to do it just straight. So a dummy load, what should a dummy load do? A dummy load should present a 50 ohm resistive impedance across whatever frequency band you're using it on. It's used for lining radios and things like that. And anytime you want to test any function of the radio and you need to transmit and you don't want the transmission to go on the air, you put it into a dummy load. Now, I will warn you that if you put 100 watts of RF into this thing, you'll be able to sense that RF for maybe 100 feet around, okay? So it doesn't cut the emissions to zero, but it cuts them so that they're very small indeed. For all practical purposes, for amateur best practices, this is good enough. You can pump your load into this and count it not being heard for very far away. Now let's take a look at what it costs. I had to go on the Chelegance website. They've got the JLoad 200 RF dummy load, 200 watts, DC to 250 megahertz. You've got the PL259 UHF male, or you can get the SO239 UHF female, which is what most people would get. It's just they didn't have any when I ordered this. It has fins for cooling, okay? No active cooling. Now, it's $59, okay? Plus whatever postage you have to pay to get it from China. Chelegance is a company that takes open source kinds of items, things, and puts them out and makes them very easy to get. Now, let me show you how I connected this for the test. And this is a nano VNA, okay? And this nano VNA, which I have calibrated, should give us a nice idea of what's going on here. Okay, so we screw that in, put it up here. This is connected to the computer via a USB cable, USB-A here and USB-C here, and that also charges the batteries. Now, we're not interested in just battery charging. You can read what we're going to do here, but it's just a whole lot easier to do it on the computer. So let's look over at the computer, and we can see what is going on. Let's see, that's about the full page right there. Okay, this is a piece of software called Nano VNA Saver. And it's version 0.6.4, but it's good enough for what we're doing here. There is a later version. So here's your sweep control up here. We're going to start at 1 megahertz and go to 500 megahertz, okay? And so that's a pretty good span there. And when we sweep it, we can get these graphs. I thought I'd do here, or 4 here just for fun. So this is a Smith chart. Remember from your extra work that you've got circles of constant SWR, and you see that it's very much clustered around the 1. This right here where my finger is pointing is where 1-to-1 SWR is. Now let's just look at the VSWR, or voltage standing wave ratio is the same as standing wave ratio, but people in the know like to say VSWR so that you know they're in the know. Anyway, I have a marker here. Marker 5 is on 15.9 megahertz. That's as close as I can get to 14 megahertz, a 20 meter band. The VSWR is 1.048, so 1.05, which is outstanding, okay? Now the next marker here, 2, is 145 megahertz, so this is in the 2 meter band. The VSWR is 1.133. Now that's not perfect by any means, but it's as close as you're going to get a dummy load to being perfect. Marker 4 out here is 225 megahertz. So this is the 1.25 meter band. Visuar of 1.163 or 1.2, which is very good. Okay, it'd be nice if antennas had that. The next marker is marker 3 over here at 435 megahertz. So this is the 70 centimeter band, and the Visuar gets better. It's 1.081 or 1.1, which is absolutely excellent. This is the actual Visuar chart from 1 megahertz all the way to 500 megahertz. Notice that on HF it's simply outstanding. And on our VHF frequencies of interest, this is 6 meters here. This is 2 meters, 70 centimeters. The response on the HF bands is wonderful, absolutely wonderful. This right here is 6 meters. Here's 2 meters. This 4 right here, they don't have it marked, but this is the 1.25 meter band. And then over here, 3 is the 70 centimeter band. As you can see, it does a very nice job. Now, my old Cantenna has a really weird looking thing over in this area here, so I'm not going to show that. This happens to be the R and J across the entire band. This is the resistance from about 44.5 megahertz. It's the green band right here, okay? And it goes on up to a little over 54. This is the reactance, okay? And you can see that it goes up a little bit here. It's not quite in sync with the resistance, but it does a pretty doggone good job. Note that this is from 43 to 55 ohms, and this is from 14 down to -2. Okay, so this is not a very wide range. This is the return loss, which you can calculate directly from the SWR curve. The worst return loss is right up here at -22 dB. So that means that the return loss is 1/100th of the applied power. That would be 20 dB. Now you add almost 3 dB to that, and so it'd be like 1/300th of the forward power. This is excellent. I like this dummy load. Now, this dummy load will not work for more than 200 watts. And if you put 200 watts in here, I think you'll feel this getting warm. Okay, and as it gets warmer, it may slightly change the resistance in here. Now, the Cantenna, which is a liquid-cooled dummy load, you can put 1,000 watts into the Cantenna dummy load. It's liquid-cooled, and you can put that in 1,000 watts for about 5 minutes, because after that, you will have heated the oil inside beyond the limits where it could possibly pop the lid off if there's some kind of boiling going on inside. At 100 watts, you can leave it on indefinitely. This one right here will heat the fins. It says 200 watts, but it could be actually handle the 200 watts continually, especially if you put a fan on it to keep the air going through the system, okay? So, very quick. It's got excellent electrical properties. It's available from Chelegance for a very reasonable price. You may have to wait 3 weeks or so for it to come from China, and I would rate this as an excellent dummy load for amateur radio work. This is not a precision piece of laboratory equipment, but it is good enough for amateur work. Okay? So there you have it. I like it. Go ahead and get yourself a dummy load for your HF radio, a 100-watt radio, so you can transmit into that, and get your audio set up, and get your compression set up, and all that without transmitting on the air. Now, I will warn you, if you tune into this, it's got nearly a 1-to-1 SWR, so you don't need to tune. But when you tune your antenna, you're going to have to tune that on the air, because it will have a different reactance. It will not have 50 ohms purely resistive. It will have something that could be quite a bit reactive also, okay? So you use this to set your radio up, but to actually tune it into the antenna, you need the tuner and the antenna to make that tune. Now you are putting out a signal over the air, and so you do need to announce it is legal to transmit for testing reasons, but you should sign testing from your call sign, testing from KE0OG. So there you have it. Until we next meet, 73.